Okay, cool. Let's go write some tests. So this is gonna look like, let's see what we got here. This is fine. Yeah, BS address. I actually want the address of BS, not BS address, not the address itself. Test FL. I'm actually gonna split this into a few things. Let's do void overflow tests. Overflow tests. So let's look at some of the weird scenarios we have. We'll just comment out everything here for now. Because there's other like more normal scenarios we need. So first weird scenario I believe is this this whole thing. So if we try to okay, easiest way to do this is to just because we're defaulting to 1024, which is not a bad idea, but makes it hard to test. All right. MD capacity is that, and store capacity is that. So all we need to do is, also let me make that a little bit bigger. A little bit bigger for now. But let's test this first one. So, full metadata. So we'll put in 1024 of these guys. So for BS equal to BS in it, and we'll do BS free BS. Actually, let me check the mallocs real quick, just make sure they all align. Malloc, 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 and there's 3 mallocs here. Okay, good. So we need to make MD start equal to MD end, and the easiest way to do this is to just insert max capacity. That'll put MD end at the 0. So this is just a test. We can use int. BS reserve. Yeah, reserve. BS size of 8, refs 1, I guess. We'll keep it 1 to make it easy. And then address holder is going to be, we'll take this, the address of the address, BS address, okay? And this will be some number, which we can ignore. Int number is equal to that, or we can do this, uint 32 num is equal to 0. Let me do num is equal to that. We can also do an assert num is equal to, if we do this 1024 times, it should be 1023. And we can make a few more assertions, such as assert BS MD start is equal to 0 because we didn't free anything. And we can do MD end is equal to also 0. And let's see if that works. You can just do make test. Okay, does not like that. need that. You good? Cool. Test BS. BS. There we go. Assertion failed. It was not 1023. Why not? Now, why would it not be 1023? What would it be? Can we print that out? Num, just real quick. What do we got here? What is the number? 0. One sec. Look at us, already catching bugs. What if it's 256? 0. Because we don't return it properly? What's going on here? What the fuck is going on? We need the metadata index, basically. It's not here, is it? This isn't it? Why, right? I swear to God. Just make sure it's not that. Okay, it is that. Cool. So for some reason we repeatedly call this, and yet it still does that, because MD start never moves from initial metadata index, which is 65536, but it should. Why is it? Right. Why would yeah, that makes sense, right? So now it'll actually work. Okay, it's still 0 though. That doesn't make any sense. Why would it be 0? But is it a different spot where... No, it's still here. Something really seems to be catching this. Why does MD start never go from this? MD start. Why would it not work? BS reserve. Well, it should work. Let's add some printfs. See, this is exactly why we need test. If I just tried to plug this into my system, we'd have like a million other things going on. MD start is MD start. Why? What's going on? This should print a bunch of times. Yes, but why? Wait, it's 0, but initial metadata index is not 0. Wait. Oh, there's your problem. okay, this is in the header. Why is it, oh, because this is equal to 0 if you cast it to 16 bits, but there you go. You need to subtract 1 real quick. Anyways, that should solve a bunch of stuff. No, it doesn't. Cool. Why would it solve anything? Okay, hold on. That can't be right. Make clean. Make test. Okay, here we go. It's more like it. It's much better. Okay, cool. So we do 1024. This should then be 1024. And we can probably get rid of that printf. And the other one. Okay, cool. Let's see what happens. Okay, it is not, okay, we're expecting 1024. It should be 1023 because the last one is, now we're going to make another assertion that start and end are now equal. So we can now test this out. Indeed, we don't have any assertion failure, so this actually passes. Now let's actually go ahead and try this out. So, this scenario, we're full. If we try to index one more, we will hit this and we will, we can actually make this more interesting, like so. If we do num, if we try to reserve, if we reserve, it'll crash immediately, but I want to shift this to 1. So if we do number is equal to bs get, so we just get, we'll get 0, which should dereference it. And this does not return anything, or it returns a void star, which is actually we can test this out. Void 0 block. And we can also do an assertion that 0 block is in fact equal to, it actually should be equal to that because it's at the beginning. And then we reserve one more, and this should be 1. And now we can do an assertion here. So this will also test out the whole mod thing. So both of these should be 1, and then we can get a more interesting case where we double the metadata. Let's see what happens. Negative. What's going on? On line 31, we did not get num. Oh, it should be 0. But then, right, because start is, it now goes from 1 to the end and then back to 0. So both of those, the start is now 1, the end is now also 1 because that's where we're going to put it next. Okay, no, num is also not 0 either. What is am I missing something? Did we not dereference it? What is num equal to? What is going on? What goes on when we call this? What's the value? Right, so we do double it, but okay. Okay, good. It does seem to be working because we wouldn't be able to reserve 1024, but we needed to dereference. We needed to, this needs to basically get rid of the 0 block, and it should get rid of the same metadata. So maybe we forgot to do something. MD start, wait. But MD start is at 1. Well, we never tested these actually. Okay, let's do an assertion here. If this works correctly, then MD start should become 1 and MD end should still be 0 because that's where we write. So let's see what happens here. On line 29, we get a failure because it's not 1. Why is it not 1? What's going on here? Why is MD start not 1? If BS number is equal to MD start, why would this not work? Okay, let's do comparison. Printf MD start D BS number BS MD start. Put a new line in there real quick. There we go. What do we got? Okay, what's going on here? BS number is 0 and MD start number is 0. Okay, so this matches. Good. What's the problem? While BS metadata.refs okay, BS number refs metadata BS MD start.refs. What's the problem here? It does not like that. BS number refs 1. Why is it 1? Did we not? It's. Why is it 1? It should be 0. Wait a minute. Because this is not actually modifying it, is it? Oh no. This is a copy, isn't it? This struct copies from the metadata into this, but it doesn't actually write into the metadata. Okay, well, this is going to look ugly, and there's going to be a better way to do this eventually, but we can just do this for now. I think... no, doesn't like that. Okay, what's up? Why do you not like that? Oh, dot refs. Wait, but then we still dereference it. How do we? Dot refs. I mean, this is valid. We can definitely get this, but I'm not sure if this is the right one. Let's see. BSM.offset. This one's even weirder, but is it BS number we need? Yeah, we don't change BS number. There. Okay. Okay, this seems to work a little bit better. I guess when we made this, we made a copy, but we actually need to just modify the actual thing itself. All right, cool. That's that. And actually, we're not getting any assertion failure, so that's pretty good, actually. Okay. Let's keep testing that specific scenario that I wanted to test, which is this one. So what actually happens here? This. Oh, wait a minute. The metadata doesn't actually hold a pointer. It only holds an offset into memory, and we can define what that memory is by swapping out this and that. Okay, let's test these out. So, all right. So if we reserve one more in this special scenario, actually, is this a special scenario or is this just a subset of... Oh no, this is metadata running out, right? This does nothing about the store, nothing at all. So we can actually, this 0 block will come in handy. Okay, so if we reserve one more, then we get to this state. Now we can try to double it. So we'll do num is equal to bs reserve, and this one should be 102.4 because we doubled the capacity, and this should be 102.4 now. And then we can make a few more assertions, such as bs start should now be 0. This should be 102.4 because we had 102.4. Now we have 102.5 because we reserved one more, so it should be 102.4 at the, oh no, maybe it should be 102.5 because no 102. Yes, this seems right. And then we can also do assert bs capacity. Capacity is equal to 2048, and we can also assert store did not get reallocated, even though we were full. Actually, shit, we were full. So let's change that 8 to something else. This is like a double scenario. Let's just do 4. 4. Okay. And we can do assert bs store is equal to that 0 block. And let's see what happens. Capacity, right, it's not capacity, it is metadata capacity, and we can also do store capacity is equal to, what is it, we say 408192. What did I call it? MD capacity. Okay. Nice. All those pass. Cool. Okay, so now we're at this larger size. What else can we do? What else can we test out? Let's see if we can test out this scenario. So do initialized, we'll call it initial, or first test. First test, okay, and we'll do or was it initial test that I call it? All right. Oh, it is first test. Okay. What do we want to do here? We want to initialize it, and then we immediately want to request a really big one. So we'll do, it's 102, it's 8192, so we'll just do 1663. No, 6. What's that fucking number? 65535. Yes. Let's see what happens. This should, oh wait, no, that's just doubling. We actually wanted to more than double. So we'll do, that. We'll quadruple it. We need a really big chunk. That's what we need. And we're gonna test this out. Then we can test out this later. Actually, we can test both of these in one simple swoop. All right, let's try that. Cool. I didn't make any assertions, but num assert num should be 0. We just put it right at the front. We can do 1300. Make it a bit more clean. Assert, yes, emd n should be 1, I think. And then we have, we can make assertions on assert capacity. Metadata capacity should not change. But the store capacity should change. Or let me assert BS store, or no, void star first store is equal to that, and then we can assert that the store actually changed. So store capacity should be something like 131072, and then store, we can actually assert that store is not the same store as 0, our first store, just to make sure that it got reallocated. And let's see what else. Ref 0 size capacity, start, end, address holder. Oh, address holder is actually kind of important. Assert BS address is equal to BS store. We can also do something like assert BS metadata 0, refs is equal to 1, and the other things we requested. Size is equal to 130,000, and offset is 0 because it's the first thing. Make sure that looks good. 3, 2, 1. Oof, did not like that. Oh, right. This is a struct. Okay, sweet. All right, no failures, which is actually pretty good. Unless we All right, next scenario to test. So we have this initial scenario that's tested out just fine. We might be able to just pass this to, wait. If MD start is initial metadata index, then this completely breaks. We can't do that. But we could just do, we could probably just do, there's a way. Basically, if we just set the MD end to be this, then somewhere else we can handle this and this and this. Yeah. Or no, we definitely need to set this there, this here, but MD end, if we just set that to 0, then we go into here, someone will fill that out. Yeah, it's a bit messy, but okay. Next scenario to test is first is greater than last dot offset, which is when we loop around and then we don't have room. We don't have room between after last and before first. So we can create this pretty easily if we just here's how we can do this. So last before first tests, void last before first tests. We can do, just to set this up, we can do something similar to this. We can do, we can reserve, wait, this is for metadata. This is specifically for, or is it? What is this? If first.offset, what is this exactly? Is this for metadata or circular buffer or the store? Store capacity, offset, last dot size, last offset plus last dot size plus size. Okay, so this is into the store. So the store doesn't have enough room, not the circular buffer. So what we can do is we can reserve, I'll make this pretty easy. We'll just do, if we have a initial of, we'll do chunks of 1024. We'll do that 4 times, or no, we'll do that 8 times. This will fill up the array, and then we can free 4 of them. Specifically, yeah, we'll free the first 4. We'll free the first 4, which we can do with bs get bsi. Yeah, bs get. So this will I'll draw this visually. Okay, so this is what it's going to look like after this, or yeah, after this it's going to look like that, then it's going to look like that. Okay. And just to keep things interesting, I'll do a single reservation of size 3048. So we'll just do num is equal to bs reserve bs 3048. Oh no, not 3048. This is 672. Yes. What is that? One reference bs address. Okay, so now we have something that looks like something like this. All right, and now we're gonna try to do this again. It won't fit, so we'll need to double it. And this is gonna look, this will actually rewrite the whole thing, starting from this, like, oh wait, actually no, this is gonna be 8, not 1, because the metadata is not done yet. But we're basically gonna rewrite this with like 4, 5, 6, 7, 8. So what we expect to see is something like this. 4, 5, 6, 7, 8, 8, 8, 9, 9, 9, then more empty blocks. So let's see what we can do here. And then it'll call it again. So we'll set up the conditions to make this possible. So basically up to here, and then we'll call it again, and that'll insert the 9. So let's see if we can make some assertions here. First of all, starting from the top, we can do assert bs md star is equal to 0. Oh, this is a this is more complicated than I thought. Metadata bs md start is equal to dot offset is equal to 0. And then for seven, should be 7. Offset is equal to 1024 times 6, 7. Nope. Okay, so far, are we even calling this thing last before test? Yes. All right, so far so good. I'll make another assertion. This is probably going to be 4 times 1024, I think. So it'll be 0, 1, 2, 3, 4. And we can also do okay. We can also do empty end is equal to 7. Okay, we want to do something here. Oh no, empty end is going to be 8. That doesn't really help, I guess. But yeah, whatever. Okay. And then at this point, we're going to make a few more assertions. MD start is still 4. MD and metadata on 8. Offset is going to be 0. And the size is 3072. Let's see what that does. Still passing, amazing. Let me just make sure I'm not going crazy here. Oh wow, so we are running it. Impressive. Okay, next thing. If we try to insert one more, it's obviously not going to fit, but this is where we can really have some fun with this. MD start should still be 4. MD end should be probably 10 now. Metadata offset on 4 should be 0, and the size should still be 1024. And then we can do a few more assertions, make sure that like the 8 is still there and the 9 is still there. Probably the most important ones. For these two sizes, it's still going to be 3072, 3072, and I think we also want to make sure that we actually resized it. So BS store is not equal to 0 block, I guess, or first store. Which, let me just get that real quick. Okay. Metadata offset 0. It's not going to be an offset of 0. 0, 1, 2, 3, 4. It's going to be at 4 times 1024. The other one's going to be at 7 times 1024. And let's see. Okay, we do have an assertion failure. That's good. That tells me something. What's going on here? Let me actually test this one first, just to make sure we did, in fact. Okay, so unfortunately BS store is still equal to the first store. It means we did not actually properly double the size. So let's see what's going on here. It should be caught here, but if it isn't, we have a problem. First offset D, last offset D, last size D, and size D. And we're just first dot offset, last dot offset, last dot size, size. What's going on here? This should be, oh, we're gonna have a bunch of them, but the last one is the most important one. All right, first offset 4096, last offset 0, last size, size. Okay, so what am I doing here? Wait, last offset is 0? Wait. Okay, no, this tells me what I need to know. Okay, so it should be this 3072 plus 3072 is... Okay, so we are hitting this. We just aren't doing it correctly. Why not? Double time. I'm gonna take a break in a second. Yes, we are doubling, but why is it... I mean, whoops. Just a little slip there. Oh, that's a different assertion, actually. That's a different assertion failure. That could be just me doing a math mistake. 11122. The offset is 4 times 1024. What is it actually? It should be 0, 1, 2, 3, 4. Yeah, the offset should be this. Let me see, at least the size is correct, right? Size is correct. Size for 9 is correct too, right? Okay. So I think we didn't do this correctly. Why not? Let's just say printf shifting block that was at D to D. BS metadata I dot offset current start. Okay, Shifting block that was at 4096 to 0. Let me make sure that matches what I'm looking at. So the block that was at 4096, what block was that? 0, 1, 2, 3, 4. So 4 goes to 0. 5120 goes to 1024. That's the 6. 6 goes to 2048. That's good. 7 goes to 7, 3072. But it doesn't shift 8 for some reason. 1, 2, 3, 4, 5. Why not? Did we... Last MD index. Oh, wait. No, because then we'll skip the last one. This is a great call. So we actually do need to do MD end. MD end. So we can't reach MD end. It can't be MD end, but it can be the one before MD end, which is what we were seeing a problem with. Okay, cool. So the block that was at 0, so 8 goes to 4096. So, and actually we don't even get any assertions after that. So I think we're pretty good on this one. Next one is going to be, I mean, I think from this block that was at, I think we're seeing that this works just fine. I think we do need to test this scenario, which is a little bit easier to test now. We don't need to loop around, but yeah. Okay, let me just make a note of that, but I gotta go. This else block needs to be tested. Cool. Where is I? Right.